Hello everybody and welcome to a new video on this channel. Today I will show you how to plot a histogram in GNU Octave. A histogram is a nice tool to show you the distribution of the random numbers inside a vector. So for example, you have a vector containing measurement data or noisy data, and you want to see how these values are distributed. And that's what the histogram is doing for you. So let's directly head over to our workspace and start the script by typing clear all, clearing all workspace variables, close all, closing all maybe opened windows at CLC, clearing the command window. And as mentioned, the histogram shows us the distribution of a vector that contains random numbers. So a random number can have a certain distribution. There are a lot of distributions out there, like Gaussian distribution or normal distribution, Weibull distribution, exponential distribution, Rayleigh distribution, and so on. And to generate random numbers, you need a random number generator that generates random numbers to specific distribution for you. And there's the statistics package from Octave where all these random number generators are built in. And if you have installed it, you can load it by typing package load statistics. So I will post you the link where you can download the statistics package in the description of the video below. And so let's generate a vector containing random numbers drawn from a normal distribution. There's the command normrnd, and with this command you can draw a certain amount, 10, 100, 1000, whatever number of samples you want, from a normal distribution with a specific mean value, let's say 0, and a specific standard deviation, let's say 1. And the next two parameters indicate if you want to generate a row or column vector. Let's create a row vector by typing 1 and then the number of samples that we want to draw from that distribution or that we want to generate. So let's call it number of samples. Let's say we want to generate 1000 samples from that distribution to fill up our vector X containing the random numbers. Number of samples. So first let's plot this time series to see how it looked like and to get a feeling for the parameters mean and standard deviation. So we create a figure and let's plot our time series or vector containing the random numbers X. The X label is the number of sample. So 0, 1, 2, 3, 4, 5 and so on. Y label will be named with value, like amplitude. And then we turn on the grid because it looks nicer. So let's fire it up. And I will switch over and show you the plot. So here is the plot of our generated random number vector containing 1000 samples drawn from a normal distribution with mean 0 and standard deviation 1. By looking closer to this noisy plot, you can estimate that the mean value actually is around 0 and that the standard deviation, so the deviation from our mean value, is around 1. So for example, let's change these values to see what happens with our plot. Let's say we change the mean value to 5 and we leave the standard deviation with 1. Fire it up again. And then you can see, our time series got shifted on the y-axis, and if we look closer to the plot, we can estimate, yeah, the mean value is around 5. If we now, for example, would increase the standard deviation, the range of the values around our mean value would get larger. And the histogram is a tool that is giving us a visual representation. For example, if we plot the result, showing us this distribution of the values. And to plot the histogram, there's the histogram command, the hist command in Octave. And to the hist command, we pass our vector containing the random numbers x, and we can tell the histograms the number of bins. So what is a bin? What a histogram is actually doing, it's taking the vector containing our random numbers, and then these random numbers, they cover a certain value range from a highest to a lowest value, min and max value, and the number of bins tells the histogram, the hist command, to slice this value range into a certain number, let's say 20. Then the hist command would slice the value range into 20 bins, and then the hist command would count the amount of numbers that fall inside each of these bins. So the bin is like a sub value range, and the histogram command is counting the amount of numbers that fall inside these sub value ranges. So we create a variable number of bins, let's say 20. This means that our vector containing our random numbers, the value range inside this vector will slice into 20 sub-value ranges, and the histogram command will count the numbers that of values that fall inside each of these sub-values. So increasing the number of bins will give us a higher resolution of the histogram. Number of bins. The output of the histogram command, so the histogram command itself also is without an output, will open up a plot window showing you the histogram, but I will show you how you plot it by yourself. And the output of the histogram here is the value count for each bin. Let's call it NN. So then the number of values that fall inside each bin and the bin value itself. The center of this, so XX is the bin value, and the bin value means that it's the center of this sub value ranges. I think it will be clearer if we plot the results. So we plot it by again creating a figure, and instead of using the plot command, we now plot the results using the bar command. This will create a bar plot. So vertical bars aligned next to each other over x-axis. So the arguments that we have to pass here are the same as we use for the plot command. We give him a vector for the x dimension and for the y dimension. The vector for the x dimension are our center values of our bins, of our sub value ranges, and on the y-axis we will see the number count for each bin. So how many values of our vector x fall in are falling inside each bin. So x label then means I call it bin value, center bin value. Oh, Alexa is talking to me. Center bin value. The y label, the count. So how many numbers or how many values from our random number vector x are falling inside each bin. So we just name it count, and we turn on again the grid because the plot looks nicer, and then we are firing up the script. First I will change our random, our vector containing our random samples back to random samples with mean 0 and standard deviation 1, because then the result looks nicer and it's easier for me to explain it. And so I will show you the result. So here it is. Here's the histogram, the bar plot. Here you can see the vertical bars, and what you can see here, yeah, this looks actually like a Gaussian distribution or a normal distribution with a mean value of 0. You see that most of the values are centered around 0, and we have a standard deviation visually estimated with 1 around our mean value. So let's, for example, increase the number of bins to 50. Then you will see that our histogram will be a bit higher resoluted. So here you can see now we have splitted our value range, which is from -4 to 4. This is the value range of our generated random vector. Is now split into 20 sub-value ranges, and on the y-axis we can see how many values from our vector x fall inside of each of these sub-value ranges. For example, in our vector x there are, let's take the value of -2. There are about 10 values with -2 inside our vector x. Or for example, let's go to 0. There are around 51, 52 values with the value of 0 plus minus this bin range. So this gives us a really powerful tool to estimate the distribution of a random number. Here we generated a random number vector from a normal distribution. That's why we see here a normal distribution. But often you don't know the distribution. For example, if you have measurement data or any other noisy data and you want to get a feeling about the distribution that these values are from, then plotting the histogram gives you a first hint what it could be. And yes, so the histogram is an estimation of the probability density function. The probability density function, I will explain it in maybe the next video. This is a mathematical description of the distribution of a certain random number, and the histogram is a estimation of that probability density function. So yeah, that's it. Short video. I hope you liked it. If you have special wishes about any other topics that you want me to make a video about, just make a comment under the video. And so, see you next time. Bye bye.